All right, last set of questions. So these questions deal with this pathway that it tells you. This enzyme catalyzes the 17th step in this biosynthetic pathway, which is allosterically inhibited by its end product. This is not relevant to this question, but it is relevant just because that's how most biosynthetic pathways work. And you know that allosteric inhibition is the inhibitor binding a separate site on the enzyme, causing conformational change that makes it more difficult to bind the substrate, or impossible. Right? All right, so there's a mutant that can't perform step 17, deaminate threonine. As a result, it can't grow. So which of the following additions would you expect to allow growth? So it's basically asking you, you're held up at this step in the pathway, how do you get to the end product? Right? You can do all these steps, which means you could add alpha-ketobutyrate, or you could just add the end product, isoleucine. Or you could add threonine and isoleucine just because threonine's irrelevant, right? It'll just be held up over here. One kind of potential hangout with this question is that, oh, so what if you needed alpha-ketobutyrate or ketobutyric acid as an intermediate from this to do something else, to go into a different pathway, right? Because there are, say, like intermediates in glucose breakdown that are important for other biosynthetic pathways. And the answer to that is that this is kind of an ambiguous question, and just the least amount of assumptions, like the kind of question with the least amount of assumptions is how do you get to the end product, right? But if you say we're thinking about that, and you did like not circle alpha-ketobutyrate for that reason, I'm sure that you get full credit if you just explained it. Say like, oh, I didn't circle alpha-ketobutyrate because it is possible that it's important to another pathway necessary for growth, like in glucose. All right, 26 and 27. What binding study for this allosteric inhibitor could explain the inability to grow, or just for the enzyme? So no growth makes sense if the mutant TDase binds threonine more tightly or less tightly or neutral, right? And what's tight? Like what measures tight binding? Is the Km, right? And what is Km? Km is basically measures how much, like the Km measures how tightly it binds, right? So more tightly is going to be a smaller Km, and less tightly is going to be a larger Km, right? And with a larger Km, what you're basically saying is you need a higher concentration of substrate to run this reaction at maximal velocity because of the Vmax doesn't change, right? And because you need more substrate, the reaction would run slower at the same substrate concentrations, which could inhibit growth. So the answer is C, less tightly. Conversely, on 27, no growth makes sense if it binds isoleucine, which is the allosteric inhibitor. I think it's pretty clear because that it's A, more tightly, because the better you bind an inhibitor, the more inhibited you're going to be, right? I think that makes sense. Last question. So suppose this boy over here can inhibit the action of TDase. When it's present at a certain concentration and a large ratio compared to threonine, it inhibits it like very well. But when present at the same concentration in a smaller ratio, it barely inhibits, right? Or I mean, it's not barely inhibits, but inhibits a lot less, right? So what you guys should be thinking of is this sounds really characteristic of a competitive inhibitor, right? Because when there's a lot of competitive inhibitor comparatively, it's going to take up a lot of this loose enzyme, and like when there's less competitive inhibitor compared to the substrate, it's going to be drowned out by the effects of the substrate. And that's why Vmax doesn't actually change, right? Because when you increase the substrate concentration enough, the amount of competitive inhibitor present just ceases to matter because it's not actually inactivating any enzyme. So you know that Vmax stays the same for competitive inhibitor, but Km increases, right? But there's nothing here says Km increases. But you got to think, what does Km mean, right? Km is the concentration of threonine needed to drive the reaction at 1/2 its maximal velocity. And what looks like that? E, the concentration of threonine needed to drive the deamination at 3/4 of its maximum velocity, which is basically saying the same thing, just measuring in a different way. So the answer is E.